Hi everyone, this is Teach Chem Forever, and today we're going to talk about limiting reagents. When a chemist carries out a reaction, the point is to try to get a maximum yield of the product. So sometimes what chemists will do is use a large excess of one of the reactants to make sure that the other reactant is completely converted and used to the desired product. If we have a reagent that's completely converted, obviously we're going to have the other reagent that's not. Well, the reactant that's used up first is called the limiting reagent, and the other one that's left over is called the excess reagent. As an example, consider this synthesis of methanol. Let's say we start off with 4 moles of carbon monoxide and we start out with 6 moles of hydrogen gas. Knowing this information, this is your initial starting material, knowing this, which one of these reagents is your limiting reagent? You can quickly figure this out by doing a mole-to-mole ratio. So I would have to basically take the initial amounts of the starting material to the product, which is methanol. If I have 4 moles of carbon monoxide, and in the balanced reaction there's 1 mole of carbon monoxide, and take that to the moles of methanol, there's also 1 mole of methanol, you'll see that the answer gives you 4 moles of CH3OH. Let's do the same thing for the hydrogen gas. I start out with 6 moles of hydrogen gas. In the reaction, I have for every 2 moles of hydrogen gas, I get 1 mole of product. So if you do this quick calculation, you'll see that this gives you 3 moles of the product. Because H2 gives you a smaller amount of the product, H2, hydrogen gas, is considered the limiting reagent. If hydrogen gas is the limiting reagent, then the carbon monoxide must be the excess reagent because some of it will be left over. There's a couple of things that you need to realize when we're doing limiting reagent problems. Number 1 is obviously knowing the difference between the limiting reagent and the excess reagent, which we just talked about. The second thing you need to understand is knowing the limiting reagent can tell you what the theoretical yield of that reaction will be. Theoretical yield is the yield of the product that you should get if everything you did in that lab experiment was perfect and you didn't lose or drop any compounds or materials. So the theoretical yield for this reaction would be 3 moles of methanol, because that is how much I can get with this particular starting material, 4 moles of CO and 6 moles of H2. I can only get maximum 3 moles of product. So there's nothing extra that you would need to do to find the theoretical yield once you know how much product you get from the limiting reagent. There's another thing called actual yield. Actual yield is what you actually get in real life when we weigh the product. If you take both of these concepts, you can figure out what the percent yield of your product is. So the definition of percent yield would be actual, and this is all in grams, actual yield over theoretical yield times 100. Okay, so I think we're ready now to do some problems. Problem number 1 asks, chlorine gas reacts with potassium iodide to yield potassium chloride and solid iodine. Chlorine gas means it's Cl2, reacts with potassium iodide to yield potassium chloride and solid iodine. Before I even keep reading the problem, we have to make sure that it's balanced. To balance it, I would put a 2 in front of the KCl and then a 2 in front of the Ki. Everything is now balanced. Let's go on and read the problem. If you start the reaction with 100 grams of chlorine gas and 500 grams of potassium iodide, how many grams of the excess reagent will remain after the reaction has run to completion? So the first thing to do here is figure out who is the limiting reagent and how much product do you actually make. To do this, I would need to take both of those initial amounts to the product. And it doesn't matter which product you take it to, but whichever you decide, it has to be to the same one for both of those starting materials. So let's quickly do that. I'm going to do 100 grams of chlorine gas. I need to convert this to moles of chlorine gas. Once I'm in moles, I can go over to a product. I'm going to pick KCl. So in 1 mole of Cl2, I get 2 moles of KCl. If I do this calculation now, it should give you 2.8208 moles of KCl. I now have to do the same process, but for potassium iodide. So 500 grams of potassium iodide, I go use the molar mass, and then I take it to the same product. If you do this calculation, you should get 3.0120 moles of KCl. It's very important that you take it to the same product because you have to compare apples to apples. So here you could see that the person that gives you the least product, right, so this is the smallest number, the least product comes from Cl2. So that means that Cl2 is your limiting reagent, which also tells you that the other guy is your excess reagent. Now the question was originally asking how many grams of the excess reagent will remain after the reaction has run to completion. After you figure out the limiting reagent, you can discard the other calculation. You really don't ever make this much. You do not get to make 3 moles of KCl. So there is no reason for you to keep that calculation. Everything else about a limiting reagent problem will come from the amount that you actually make. And now you can find how much excess is left over. To do this, you would need to take how much you made, and you would have to go backwards, do a multimole ratio back to the excess reagent. The excess reagent is your potassium iodide, but it's asking for how many grams. So now I have to go a step further. I'm in moles of the excess reagent, but it's asking for the grams of the excess reagent. So I have to now use the molar mass of Ki to get how many grams I would have. If I do this calculation, it should give you 468.2528 grams. It's very important that you understand what this number means. 468 grams is the amount of grams that was used to make this product. So therefore, when you bring it back to the excess reagent, this tells you how much grams was used to make that amount of product. They're not asking for how much was used. If you remember on the problem, it says how much is left over, how much remains after the reaction is done. So to do that, I would have to take the starting amount, which is 500, minus 468.2528, which means you should get an answer of 31.7472. I would just go ahead and say 32 grams of Ki is left over after the reaction goes to completion. I want to do one more problem, and this is asking for percent yield. So it says when heated, solid lithium reacts with nitrogen gas to form solid lithium nitride. First thing I have to do is balance it. A 2 here and a 6 here. So now what is the question actually asking us? What is the theoretical yield of lithium nitride in grams when 12.3 grams of solid lithium are heated with 33.6 grams of nitrogen gas? So this is my starting amounts. So we would take 12.3 grams of lithium and take this to the product. So I would use the molar mass and then use a multimole ratio. It's asking for grams, so I'm going to go ahead and go one step further. In 1 mole of lithium nitride, I have this many grams. Fill in those numbers, you should get 6.941 grams for 1 mole of lithium, and lithium nitride is 34.833. Doing this calculation, you should get 20.5756 grams of Li3N. I have to do the same process for nitrogen gas, so I would do 33.6 grams of nitrogen gas, use the molar mass, and then use the balance reaction to go from moles to moles. So I use 1 mole of N2 to get to 2 moles of lithium nitride. I have to go one step further to get to grams. Doing this calculation, you should get 83.539 5 grams of lithium nitride. Obviously, the limiting reagent here will be the 20 grams, which comes from the lithium. So your limiting reagent is lithium, your excess reagent is going to be nitrogen gas. They wanted to know what the theoretical yield was. This answer right here is the answer to that. The theoretical yield, the maximum you can make with that much starting material, is 20.5756 grams of lithium nitride. I obviously have not adjusted it for sig figs, but that's the answer. The next part of the question would ask if the actual yield, so this is considered the theoretical yield, if the actual yield of lithium nitride is 5.89 grams, so this is what you're supposed to get in a perfect world. But when you actually do this experiment, you weigh out your product and you only get 5.89 grams. They want to know what the percent yield for your experiment is. To do this, I would use the equation of percent yield, which, to remind you, is actual over theoretical times 100. So you actually get 5.89 grams. You should get, theoretically, 20.5756 grams. If you take this and multiply it times 100, it'll give you the percent yield, which is 28.6%. To be honest, that is not a very good percent yield, but that is how you would do this problem. I hope you guys enjoyed this video. Remember to please read this section in the book and watch this video before we get to class. And of course, think about these reflection questions as you're doing the problems. All right, guys, see you later.